AP Calculus first semester final, 2019 version. 2 weeks ago we had our final, and there are 22 problems total. The first 10 of which are assigned to do without a graphing calculator, and then the last 12, the graphing calculator is permitted. So anyway, problem 1, we have the limit as it approaches infinity of this expression 3n cubed minus 5n plus 1 over 1 minus 2n squared minus n cubed. As you go to infinity, what happens is you look for the highest exponentiated terms in both the numerator, in which case we have 3 n to the power of 3 over the highest power term in the denominator, which is negative n cubed. And what happens is you'll notice that n cubed over n cubed will cancel each other, simplify to negative 3, which gives us our answer B. So this is what we call, if the exponents are the same, at bottom high exponent equals top high exponent, you use the ratio of the coefficients, 3 over negative 1, which is a horizontal asymptote, by the way. Next, problem 2. An equation of a line tangent to the graph of y equals 2x plus 3 and 3x minus 2 at point 1, 5 is, and you have answer choices. This is what's called a rational function, a ratio of two functions. In ratios, where we have one function divided by another, we can use something called the quotient rule. And use that quotient rule, we're going to find first what low is. The low is going to be 3x minus 2, and d low is equal to 3. And we have high is equal to 2x plus 3, and d high is equal to 2. So our derivative, y prime, is going to be equal to low d high, low d high, minus high d low minus high times d low, all over. I'm going to start high. Anyway, that's it. So let's go ahead and work this to the right. So we have low, which is 3x minus 2, d high, which is 2, minus high, which is 2x plus 3. You notice we had to put these binomials inside parentheses. 2x 3, okay, I think that's right. Okay, all over low squared, and low being 3x minus 2, we square that. And then we continue working to the right, and we can use our distributive property on this 2. So we get 6x minus 4 minus, and we're going to have 3 times 2x, that's be minus 6x, minus 9, all over rho squared. Well, that's going to be 23x minus 2 squared. And I forgot to mention at the beginning, to find an equation of a line, we're going to need two things here. We need to have a point, and the point we are given is 1, 5. A lot of times in these problems, you're given only an x value to start with. In this case, they gave us 1, so it's a little work. Our slope is, I'm going to label m sub t, and it's going to be equal to something we're going to need to find out. If we have the point and the slope, we're going to be able to have the equation of the line. But anyway, let's go ahead and simplify this out. We have 6x minus 6x will cancel each other. And then we're going to be left with negative 4 minus 9, so we'll get negative 13 over 23x minus 2 squared. Now, we're going to find y prime where x equals 1, and we're going to simply substitute in 1 for x. So if we substitute in 1 for x in the denominator, 3 times 1 is 3, so 3 minus 2 squared. So this is going to simplify. Let's try to get this a little more legible. So we have 3x minus 2. That's a little better. Squared, which is going to be 1 squared. So we have negative 13. So using our point slope form, which is going to be y minus y1 equals m times x minus x1, we're going to have y minus 5 is equal to m, which we found to be negative 13. And we have x minus 1. And you see we have all these different forms in here. Let's go ahead and just kind of simplify. It looks like we're going to need that standard form, just the number on the right and all the variables on the left. So on the right side, we're going to have negative 13x plus 13. And to solve this, we can add 13x to both sides of this equation. And then we have y plus 13x minus 5 equals 13. And then if we add 5, we get y plus 13x equals 18. And we have that up here. That's choice B. Let's go on to problem 3. Again, we have a tangent line problem. And for that, we're going to need to have two things. What are they? A point and slope. For a point, well, we're given our x-coordinate for our point. We have 2. And we go ahead and find what that corresponding y-coordinate is. So if we put in f of 2, it's going to be equal to 4 times 2 cubed minus 3 times 2 minus 1. And 2 cubed is 8. 4 times 8 is 32. And then 3 times 2 is 6. So we get 32 minus 6 minus 1, which equals 25. So that's going to be our y-coordinate, 25. And next we need our slope. And we'll put down m sub t equals, we'll find our first derivative, f prime of x is equal to 3 times 4 is 12 x squared minus 3. And if we plug in 2, f prime of 2 is equal to 12 times 2 squared minus 3. And 12 times 2 squared, so that's 48 minus 3, so it equals 45. So m sub 2 equals 45. And going to our point slope form, we have y minus y1, which is 25, equals m, which is 45, times x minus 2. And then you'll see our slope is 45, so answer choice A, D, E are gone. Okay, so now let's just distribute on the right side. We get 45x minus 90. Left side we have y minus 25. We add our 25 on both sides of the equation. We get y equals 45x minus 65. And which one is that? Let's choice C. Okay, next, 4. The absolute maximum value of fx equals x cubed minus 3x squared plus 12 on the interval from negative 2 to 4 occurs at x equals question mark. For this, we can use something we call the candidate test, where we put our endpoints, our candidates, and any critical numbers we should find. So we have x and f of x. We know that endpoints can be maximum. And by the way, this is the absolute value theorem. So x equals 2, x equals 4, and anything else we see in between, which could be some of these other answer choices. So let's go ahead and it's a fact. I think because of these answer choices, we could actually enter all of these if we want to, right? See which one gave us the highest value. We would know that would be our answer. But I just want to go ahead and work out the calculus on this. It's not a calculus and stuff. Anyway, we'll say f of negative 2. Now just to work these out before we find our critical numbers. It's going to be negative 2 cubed minus 3 negative 2 squared plus 12. Well, negative 2 cubed, that's going to be negative 8. Negative 8 minus 3 times 4, so minus 12, plus 12. So negative 12 plus 12 equals negative 8. So we have that. F of 4 equal to 4 cubed minus 3 times 4 squared plus 12. What's that going to be? 4 cubed, 64. And then minus 3 times 4 squared, well, that's 6. 4 squared is 16 times 3, so minus 48 plus 12. So for that, we get 64 minus 48 is 16. So it's 16 plus 12 equals 28. So 28 is our value here. Next, we're going to find a critical number here. So we'll take our first derivative, f of x is equal to dx squared minus 3 times 2, which is 6x. And that's it. And if we set this equal to 0, we can factor out a 3x in each of these terms. We're going to get x minus 2. So we have x is equal to 0, x is equal to 2. as our other, so 0, 2, and our we have 0, that's going to be a y-intercept, which is going to be f of 0 is equal to 12. And now we just have to find f of 2. F of 2 is equal to 2 cubed minus 3 times 2 squared plus 12, which equals 8 minus 12 plus 12, which is going to be equal to 8. So therefore, at x equals 4 is where we have our absolute maximum, which is choice A. Next, 5. At x equals 3, the function given by f of x equals x squared when x is less than 3, and 6x minus 9 when x is greater than or equal to 3 is, well, we know because of this greater than or equal to sign, we know that we have the function defined. So therefore, we know that A is not a correct answer. And then beyond that, let's see. Continuous. Now you have to have continuity first before being differentiable. So you can't have differentiable without continuity. So C is not a correct answer choice either. So get a little elimination. Now we're going to test first of all for continuity by taking the limit as x approaches 3 on the left side of f of x, and setting that equal to the limit as x approaches 3 on the right side of f of x. And for the left side, we have x squared. The right side, we have 6x minus 9. And now substituting 3, we have the left side 3 squared is equal to 6 times 3 minus 9. So we have 9 equals 9. So B is not correct either. So we're just between the answer choices B and E. Next we test for differentiability by seeing not if the limits as x approaches 3 on the left side of f of x, it's f prime of x. And so we take the derivative, the first derivative of each side. So this derivative of x squared is 2x on the left. The derivative of 6x minus 9 is 6. And now substituting 3, we have 2 times 3 is equal to 6. Correct. So we have both continuous and differential for our answer for problem 5. Next, 6. F of x equals square root of 2x. And we'll find f prime of 2. So I'm going to take the first derivative of this function and then plug 2 into that first derivative function. So first of all, I'm going to rewrite this in calculus-friendly form. Square root is to the 1/2 power. So I'm going to rewrite this as 2x to the 1/2 power. Now f prime of x, you multiply by 1/2. We take this 2x, and we take this 1/2 minus 1, which is negative 1/2. And lastly, using a chain rule, we multiply by the derivative of the inside function, which is 2. So we have 2 times 1/2 that cancel each other. So we're left with f prime of x is equal to 2x to the negative 1/2 power, which is equal to 1 over square root of 2x. And now we can plug in 2, f prime of 2 is equal to 1 over square root of 2 times 2, which is 1 over square root of 4, which is 2. So our correct answer is B. Next, 7. We have integration. And what I'm going to do is we take an integral of the square root of x times 20x plus 2 dx. So we can distribute this square root of x to both terms inside the binomial there. So we have that equal to the integral of, right down here, x, the square root of x is x to the 1/2, and x to the 1/2 times x is going to be x to the 3/2, and then we have plus 2x to the 1/2 power. And then we multiply all this by dx. And now taking the derivative, an integral, we have x to the 3/2 plus 1, which is 5/2. And when we divide by 5/2, which is the same as multiplying by 2/5. And we should already be able to see, I think, mostly from our answer choices, where we're headed with technical choice B. Plus 2, we have x to 1/2 plus 1, which is x to 3/2. And we multiply, we divide by 3/2, which is the same as multiplying by 2/3, plus our constant integration c. So we get 2/5 x to the 5/2 plus 4/3 x to the 3/2 plus c. So that's it. That's our answer there. And that's D. Next, 8. If the limit as x approaches 3 of fx equals 7, which the following must be true. 1. F of x is continuous if x equals 3. And I hope you can remember from the beginning of the course that you can't have a sketch graph here, right? And we have 7 right here. And we have x equals 3 down here. So what happens is, when you have this limit, it could look something like this. You could have just a hole and be going like this, and have this break in continuity, and then resume on the other side of the hole. And so you don't necessarily have to have that function continuous if there is a limit. So 1 is not necessarily the case. And if we are not continuous, can we be differentiable? No. And in this case, where we have an actual hole there, is f of 3 defined as 7? No, it's not defined according to the sketch and drawing I made. So based on what must be true, none of those statements. Next, 9. Given f of x equals 2x squared plus 1, instantaneous rate of change at x equals 3 is how much greater than the average rate of change between x equals -1 and x equals 2. I hope you remember that your average rate of change is going to be f of b minus f of a over b minus a. So we will define that x equals -1 to be a, and x equals 2 to be b. So a is -1, b is 2. So now we're going to find f of b equals f of 2, which equals 2 times 2 squared plus 1. And 2 times 2 squared, that's 2 times 4 plus 1 equals 9. And f of -1 equals 2 times -1 squared plus 1, which is going to be 3. So what we have here for our average rate of change is going to be f of b, which is 9, minus f of a, which is 3, over b, which is 2, minus -1. Okay. We have a 6 divided by 3, which is 2. Now next, the instantaneous rate of change at x equals 3. So to find our instantaneous rate of change, we find our first derivative, f prime of x is equal to 2 times 2, which is 4x. And f prime of 3 is equal to 4 times 3 is equal to 12. So that's an instantaneous rate of change. Find the difference. We use 12 minus the average rate of change, which is 2, which is 10. So our correct answer, problem 9, is B. Next, 10. The cost of producing X number of bicycles is given by C of X equals X cubed plus 48 over X. So the interval from 1 to 10, what is the minimum cost? I don't know how easily you can see this, but this is an absolute value problem. I will show you here. What we have is this candidate test, like we worked out in an early problem. We put X in C of X. If we plug in our endpoints, which are going to be 1 and 10, I'm going to leave a little room here in between. And C of 1 is equal to 1 cubed plus 48 over 1, which is 49. So we know we have that one in the back, so we know answers cannot be D or E already. Next, we're going to plug in 10. C of 10 is equal to 10 cubed plus 48 over 10. The 10 cubed is 1,000, and 48 over 10 is 4.8. So we have 1,000 and 4.8. So not a correct answer. Next, we're going to look for any critical numbers to see if we have one of these other two answers. besides c. We're going to find our first derivative and set that derivative equal to 0, or where that derivative is undefined. So I'm going to rewrite this in calculus friendly form. C of x equals x cubed plus 48 x to the negative 1 power. And now c prime of x is equal to 3x squared. And we're going to find this derivative here. So negative 1 times 48 is going to be minus 48 x to the negative 2 power, which is going to be equal to 3x squared minus 48 over x squared. And if we set this equal to 0, 0 equals 3x squared minus 48 over x squared. And we add 48 over x squared to both sides of this equation. We get 48 over x squared is equal to 3x squared. And working on the right, if we cross multiply the x squared, we get 48 is equal to 3 x to the 4th power. And if we divide by 3, we get 16 equals x to the 4th power. And taking the 4th root, we get x is equal to plus or minus 2. And we know we're only going between 1 and 10. So we know that 2 is going to have to be a critical number we look at. We can just plug this in. C of 2 is equal to 2 cubed plus 48 over 2, which is going to be 8 plus 24, which is equal to 32. Our answer choice A. Next, we're going to be going on problem 11. Now we're to the section of the test that I arbitrarily assigned to be the calculator section. So I don't think we have to use the calculator in any of these. Some of these are the usual calculator for us. The graph of y equals f of x on a closed interval from negative 3 to 7 has the following endpoints: negative 3, 4, and 7, 1. F of x is continuous on a closed interval, differentiable on open interval. From negative 3 to 7, there exists an x value c between negative 3 and 7 such that this is an existence theorem. Must or has to or exists. In this case, what we're looking at is basically existence theorems are intermediate value theorem, mean value theorem, Rolle's theorems, and absolute value theorem, which we've already covered in this test problems. So, and we have done mean value theorem too. We had the problem for a while. But anyway, we're going to take, let these equal A and B. And so f of B, f of 7 is going to equal to 1. F of negative 3 is equal to 4. So A rock, and by the way, for there to be a possibility of this being right, we have to be continuous and differentiable. There's nothing like a function here to tell us, so we have to be in the text informed that that is the case, which we are informed of. So we have f of b, which is 1, minus f of a, which is 4, over b, which is 7, minus negative 3. And so we get -3 in the numerator and 10 in the denominator. So we know there has to be an x value such that f prime of c is equal to -3/10. That's choice B. Next, 12. Function f is defined on the interval from -5, 5, and its graph is showing the right which the following statements are true. The first one, let me kind of expand this a little bit, make it a little more visible. Statement 1, the limit as x approaches 1 of fx equals -1. So the limit, we're approaching 1 from the left side and from the right side. And we have f of 1 defined as -1, but the limit really is -2. So that is not a true statement as written. Next, the limit as h approaches 0 of f of 2 plus h minus f of 2 over h equals 2. Now this is the form of definition of derivative. So I hope you remember when we did that with the secant line, and we simplified and worked out some problems before using the power rule. That's what this is. So what it's telling us is that this is the slope where x is equal to 2 is equal to 2. That's what it's saying. Now, is that the case? Here we go where x is equal to 2, and we have a line here between x equals 1 all the way up to x equals 3. And what's the slope of that line? Well, up 2 over 1, up 2 over 1. So yes, that is correct. Our slope is 2. So condition 2 is correct. So looking at choices, 1 is wrong. 1. Now between 2 only and 2 and 3 only. Let's go down to 3. Statement 3, limit as x approaches -1. That's a plus sign to the right. So we go -1 to the right. There's -1. And from the right, we're going to get 1 is equal to f of -3. Let's go to -3. And what is our output value? 1. So does 1 equal 1? Check. So condition statements 2 and 3 are valid. Next, 13. Now, I did enable you to put a calculator in your hand for this one. And so that being the case, you could substitute these values, answer choices in here. If you can go about it strategically, probably you might want to start at the middle. It looks like we're going to get bigger numbers as our input values get bigger because the way this integral is constructed, the 2x cubed plus kx squared plus 2k. So I would start at 1, and if that has to be less than 12, you could do these other choices, D and E. So that'd be a calculator strategy. Let's go ahead and do this without a calculator if you can. So let's go ahead and take the integral of this and use this equation. So the integral of 2x cubed is going to be 2x to the 4th power divided by 4 plus, let's say plus 2x to the 4th divided by 4. Let's say plus, I'm going to say minus k. And then we're going to have x to the 3rd power divided by 3. And then we're going to have plus 2kx. And we're going to go between 0 and 2, and that's going to be equal to 12. So once we substitute in for x, we're going to have the equation. This 0 kind of makes our life easier because all we have to do is first substitute in for 2. So what we have here is 2 divided by 4 is 1/2. So we get 1/2 to the 4th power minus 2 cubed over 3k plus 2 times 2, which is 4k is equal to 12. And so what we have on the left here is 2 to the 4th power 16, 1/2 that is 8. So 8 minus 8/3 k plus 4k is equal to 12. And if we subtract 8 from both sides of this equation, okay, there we go. And then, so on the right, we're going to have 4 after subtracting 8. And on the left, we're going to have negative 8/3 k. And then 4k is going to be, that's going to be the same as 12/4. Okay, why did I do that? To get a common denominator. So on the left side now we have 12/4. So we have, left side we have, oops, 12/3. Oops, 4 is the same as 12/3. There we have common denominator. So we have negative 8 plus 12. So we get 4/3 k is equal to 4. And then if we cross multiply, working to the right, we have 4k equals 4 times 3, 12, and we divide by 3, divide by 4, k is equal to 3. And we can do this in a calculator too, if we just to test this, and we have a calculator in hand. So if we put in from 0 to 2, we have 2x cubed minus k is 3, so 3x squared plus 2 times 3 plus 6 dx. If E is our correct answer, as we picked out here, we should get 12. We'll go and calculate. We figure this out, go to math, and 9. We go from 0 to 2, and inside here, we're going to put in 2x cubed and we had, what is that, minus 3x squared, is and we have plus 6 dx. I think we get 12, we get 12, we get 12, yes. Okay, that's right. Let's go on 14. Expand this one a little bit too. For a function whose values are given in the table above, the integral from 0 to 4 fx, 0 to 6 fx dx is approximately equal to sum, whose value is midpoint of each of 3 intervals of width 2. The approximation is, before that we'll say estimate or approximation of 0 to 6 f of x dx. And for this, we're given 3 subintervals. So we go, I just put 3 blanks separated by two plus signs. That's it. And we know that we have width, each one is width 2. So 2, 2, 2. So to have 3 subintervals, we're going to have a midpoint for this first subinterval I'm now encircling. Our mid value is going to be 0.25. And in our next subinterval, which I'm now circling, our mid value is going to be 0.68. And then lastly, our final subinterval, our mid value is going to be 0.95. Now this could be done without a calculator, but we can use a calculator according to what we have. So let's just go ahead and put this in here now. 2 times 0.25 plus 2 times 0.68 plus 2 times 0.95, we get 3.76. Answer choice D. Okay, next. Use the table below to answer problems 15 through 18. Particle velocity is given in feet per minute in the table. What is the minimum number of times the speed of the particle had to be exactly 5 feet per minute? Again, has to be. That's the existence theorem, which is going to be intermediate value theorem, mean value theorem, Rolle's theorem, absolute value theorem. So what we're looking at is we're talking about speed, and one thing that we have to remember, speed equals absolute value of velocity. And so we got to worry about not only where the thing crosses 5, but also crosses -5, right? So what we have is, to get from 4 to 8, we have to cross 5. To get from 9 down to 2, we have to cross 5. To get from 2 down to -7, we have to cross -5. That's the third time. And to get from -7 to 1, we have to cross -5 again. So that'll be 4 times. So we put down according to intermediate value theorem 4 times. And to fully articulate this, we would write this. We would say 5. We can put every instance that 5 is greater than v of 0, but less than v of 2. So that's one instance. Going the other way, we have 5 is greater than, we're going the other way here, greater than v of 7, but less than v of 5. So that's 2 instances. So that would be, now the next one, we would put absolute value of v of 7 is less than absolute value of -5, which is less than Put absolute value backwards. Absolute value of B of 10. And the last one we're going to have is absolute value of -5 is greater than absolute value of 12. 12, which is less than absolute value of B of 10. 4 times. 1, 2, 3, 4. Use the datum table to estimate the acceleration of the particle at t equals 4 minutes. Show correct units. Well, the acceleration is going to be the next level down from velocity, and we can find out it's going to be the average rate of change of velocity is what that's going to be. We can't find exactly what acceleration is with this table. There's a table to estimate. So that's going to be according to A rock equals f of b minus f of a over b minus a. And we're going to get, just writing this down, and 4 is going to be in between these. So 4 will be between 2 and 5. So our estimate is going to involve these things. So we will say b is equal to 5 and a is equal to 2. So let me just articulate this properly. Estimate of acceleration, which I'll put down as a of 2, equals average rate of change of b of 2. And we're going to have 9, which is f of b, minus 8 over 5 minus 2, which is going to be equal to 1 over 3. So equals 1/3, and what are the correct units? Let's say feet per minute squared. Okay, so that's going to be our estimate of acceleration. What's the average rate of change in velocity in the interval from 0 to 12, which is going to be our estimated acceleration in the interval? Before that, we would have a different a and b. We would have a is 0, b is 12. So we would have 1, which is f of b, minus 4 over 12, which is going to be -3 12ths, which equals -1/4. That's going to be feet per minute squared. Okay. And is there a time when the particle's acceleration had to be exactly -0.25 feet per second squared to justify? Yes, because we did number 17 properly and found that to be -1/4 feet per minute squared. So we say yes. According to MVT, mean value theorem, since a rock on interval of 0 to 12 is equal to negative 1/4. There has to be at least one time. I'll just say there has to be a time when a of t is equal to negative 0.25 feet per second squared. Okay, so that's 15 through 18. Let's go on to 19. A tank is being filled with water at the rate of 300 square root of 2 gallons per hour with t is greater than 0 measured in hours. So basically, for the amount, what we're looking for is amount is equal to our initial amount plus our integral from 0 to c of f of t dt. So in our case, what we have is we said the tank is originally empty, so f of a of t 0 is 0 plus the integral over 4 hours of 300 square root of t dt. So what we have here is, I'm just going to look at the right, we have, I'm going to just put the 300 outside here. 300 becomes the coefficient integral of t to the 1/2 power dt. And we're going from 0 to 4. Let's go ahead and put this in here. I'm just going to work below. We have this 300, and then we have t, and add 1 to that, so 1/2 becomes 3/2. And we're going to divide by 3/2, which is same as multiplying by 2/3. And we're going from 0 to 4. And so what we have is, let's only work the right, we have 300 divided by 3, that's 100 times 2. So we get 200. We're going to have 4 to the power of 3 halves. Well, and we have minus 0, so that would be, that's not going to be anything. So what we have is 200. Square root of 4 is, well, I'm just going to write it out here. We're going to have square root of 4 to the 3rd power. The square root of 4 is 2, so we're going to have 200 times 2 to the 3rd power, which is 200 times 8, or 1600. So that'll be answer choice D. And of course, we can do this in a calculator. I'm allowed to use a calculator on this. Again, math 9. We're going to go 0 to 4. We're going to have 300 square root of x dx 1600. Okay, number 20. A particle moves along the x-axis. Position for x is greater than or equal to 0 is determined by function fx equals x cubed minus 9x squared plus 24x for what values, the value of x is particle left. What we're going to do is we're going to find where the velocity is equal to 0. To find that out, we're going to take our first derivative, so f prime of x is equal to 3x squared minus 18x, and we have plus 24. And we're going to set this equal to 0, and we can factor out our common factor in this is 3, so 3 times x squared minus 6x plus 8. So we can divide by 3, and we have 0 is equal to, if we factor this, we're going to have 20x minus 2 times 20x minus 4. So what values of x, say where, when, or where, it's time, right? What values of x? Usually it's time, but anyway, we'll say where x is equal to 2 and x is equal to 4. So those would be our correct answers. Next, what is the integral from 5 to 1 of 3 dx? Well, basically what we're looking at here, again, you can use a calculator on this, according to arbitrarily what section. So we're talking about 3, so y is equal to 3, and we're going from 1 to 5. So we're talking about the area of this rectangle here, which is a 4 by 3. The matter of complication is that we're going the reverse direction. So we're going to have our answer is going to be negative 12 because of the limits of integration being reversed from what you normally expect to see. So let's go ahead and look at our calculator too. Again, math 9. We're going to go from 5 to 1. We're going to go here 3 dx. We should get maybe 12. There you go. That will be our answer. Okay, 22, which is our last one here. Ball thrown in the air has acceleration given by function f. A of t equals negative 9.8 meters per second squared. The ball velocity at t equals 1 second is 35 meters per second, and its position is 80 meters from ground level when t equals 1 is a function for the position of the ball, where t is greater than or equal to 0. Well, first thing, we're going to find out our velocity, v of t is equal to the integral of a of t dt, which in the case of this problem is integral of negative 9.8 dt. Okay. So just, I guess I'll look below. So we have is negative 9.8 t plus c. And now we're told what ball's velocity at t equals 1 second is 35 meters per second. So that's v of t. So velocity, okay, 35, so 35 meters per second equals negative 9.8 times 1 plus c. And so if we add 9.8 to both sides here, okay, plus 9.8 plus 9.8, we're going to get 44.8 a c. So v of t is equal to negative 9.8 t plus 44.8. So that's going to be like our initial velocity, 44.8, and then the velocity is going to decrease as time goes on. And so the next one we're going to have is our position, x of t, is going to be equal to the integral of v of t dt, which is going to be equal to the integral of, we have negative 9.8 t plus 44.8 dt. And now we take our integral. So what we have is x of t, our position function, is equal to negative 9.8 t squared divided by 2 plus 44.8 t plus c. And that's going to be negative 4.9 t squared plus 44.8 t plus c. And now we're going to substitute in 80 meters from ground level when t equals 1. So we're going to put 80 is equal to negative 4.9 t squared, and t is 1, plus 44.8 times 1 plus c. And so we're going to get negative 4.9 plus 44.8. That should be 39.9, right? Negative 4.9 plus 44.8. Yeah, 39.9. So 80 is equal to 39.9 plus c. And if we subtract 39.9, we're going to get c is equal to 40.1. So our x of t function is going to be, let's plug that in for that c there. So I get x of t is equal to negative 4.9 t squared plus 44.8 t plus 40.1. Kind of ran out of room with this watermark thing. Anyway, so that's going to be it. I hope this will help you. Good luck, and thanks for viewing.